Hi, I'm Dr. Chanabhat Tirupati, Associate Professor, Department of Civil Engineering, Session Institute of Technology. So, welcome to the today's session. So, last session we have discussed about the pressure and how to measure the pressure. And now today's session we are going to deal with pressure, how to measure the pressure at a point and when it is in equilibrium condition, and also we will discuss about the Pascal law, and we will try to derive the expression for Pascal law. Yeah, the first thing is here pressure at a point. Yeah, fluid pressure at a point. So, for example, there is a container and which is having a liquid, right? This is the head of the liquid available, H. You can say this is the free surface of the liquid. Now, how you will measure pressure at any point? So, now we will discuss about how to measure a pressure at any point. For example, you want to measure the pressure at this point. This is the point where I need a pressure. So, how to measure it? So, that we will discuss here. Okay. Yeah. Now I have, for example, this is the free surface of the liquid, water is flowing. Okay, this is the water is flowing. So there is a fluid mass, right? This is completely a fluid mass. So I have considered a small area in the fluid mass, that is dA, area of the fluid mass, a small element. I have considered a small fluid element at this point in a continuous fluid, that is the area of the fluid mass. The area of the fluid mass I have considered as a dA. This is the small area of the fluid mass. Entire the fluid mass I have considered a small fluid element which is having an area of dA. Now, if you see, we know that the pressure we have discussed in the previous session, the pressure always act normal to the surface. The pressure always act normal to the surface. For example, this is the fluid point. So the pressure always act normal to the surface, right? So which is normal to the surface. It is always act normal to the surface. We know that. The force acting on this small area of the fluid mass dA is dF. So I have considered the force acting on the small fluid element of area dA is dF. So I have considered a small fluid element which is having an area of dA, and the force, we know that it's always at normal to the surface. The force acting on this small fluid element is dF. So what is the pressure? We know that the pressure is nothing but force per unit area, right? This is we know. Now what is the pressure here? What is the pressure acting on the small fluid element, or pressure intensity, which is represented with a small p? The pressure intensity is nothing but the force acting on the fluid element and the area of the fluid element. This is the pressure intensity. This is the way to measure the pressure at a point. So now this is for a small fluid element. What if the pressure, the force is acting on the fluid element uniformly all over the surface? Then what is the pressure? So now you will get, this is the pressure force, total pressure. So for example, this is dP, this is, you can say, this is P1, and another pressure is acting on this fluid element P2 and P3, P4, P5, P6, P7, P8, P8, P9. So in all the direction, the pressure equally distributed in all the direction. So what is the total pressure? If you integrate, you will get, so integration of P and integration of dF by dA. If the pressure is equally distributed, then what is the expression for pressure? Then it is P is equal to F by A. This is the expression to measure the total pressure force. So this is the expression for total pressure intensity. What is the pressure force? So the pressure force is F is equal to P into A, right? This is the total pressure force or total pressure. You can call it as a total pressure or pressure force or pressure force. Okay. Again I will tell you. So I have considered a small fluid element in a fluid mass which is having area dA. We know that the pressure intensity always act normal to the surface, right? So now I have considered what is the pressure. Pressure, we know that force per area. So here the pressure acting on the fluid element is P1. So this is P1. I can say P1. So what is the P1, and what is the pressure force? So what is the force acting on the fluid element is dF, small element area, and area of the surface is dA. dF is the force acting on the small elemental area dA. So that what pressure intensity is equal to dF by dA. This is for one fluid element. What if the pressure is acting uniformly in entire the fluid mass like this? So it is integration, right? You will get, so that means integration of P, you will get P, that is the pressure intensity, F by A. So pressure intensity is nothing but force per area. This is the expression for pressure. So what is the pressure force? We know that this is the pressure intensity. If you multiply it with area, you will get force, right? So pressure force or the total pressure is nothing but pressure into area. This is the way to measure the pressure. See, this you need to understand. The pressure force or a pressure force or a total pressure is nothing but pressure intensity into area of the fluid mass. So what is the units? So it is kg per meter square in MKS system or Newton per meter square in SI system, right? So it is kg force per meter square, force mass by area. Here in SI system it is weight by area. Force is nothing but weight, right? So which is nothing but this Newton per mm square is nothing but Pascal, which is represented by PA. Right? We already know kilopascal means 1000 Newton per meter square. Bar, 1 bar, we discussed in the atmosphere. Atmosphere is represented with bar, right? So 1 bar is equal to 10 to the power of 5 Newton per meter square. We already discussed 1 bar is equal to 101.325 kilo Newton per kilonewton per meter square. This is what we have discussed, right? Okay, kilonewton per meter square. This is what we discussed. Okay, I hope you understand the concept. This is the how to measure the fluid pressure at a point. Okay, we'll go to next slide. Yeah, now the very important concept in the fluid mechanics, Pascal law. So now we are trying to understand what is Pascal law. So what Pascal law will state is, Pascal law will state that the pressure intensity of when the liquid is equilibrium condition, which is equally transmitted to all direction. So it said that the intensity of the pressure at a point, for example, if you consider a fluid, right? This is the fluid which is in a container. So for example, this is the point. If you want to find out the pressure intensity, so pressure intensity in a static fluid. Static fluid means the fluid at rest. So the Pascal law is applicable for only when the fluids are at rest condition. So the intensity of the pressure when the fluid at rest is equal in all directions. So which is equal in all directions. So for example, if you measure the pressure in this direction, Px will be equal to Py will be equal to Pz. In other sense, this is the point pressure. So if you measure the pressure here, or here, or here, or here, or here, or here, so the intensity of the pressure is same. So that is what Pascal law is. So what Pascal law will state that? Pascal law will state that the pressure intensity when the fluid at rest, this is a very important condition, a static fluid or fluid at equilibrium condition. So the intensity of pressure is equal in any direction. So with respect of the direction, the pressure intensity is same. In other words, you can say Px is equal to Py is equal to Pz. So what is Px, Py, Pz? Px is the pressure intensity in the x direction, and Py is the pressure intensity in the y direction, and Pz is the pressure intensity in the z direction. So where we can use this Pascal law. So normally when you see hydraulic jets or hydraulic lift, hydraulic ramps, so we will use this Pascal law. So we will discuss with we'll try to solve some numerical problems, then you will understand the better how it is going to help, right? So again I will tell you what Pascal law is. Pascal law states that the pressure intensity when the fluid at rest or equilibrium condition or a static fluid is equal in all directions. So with respect of the direction, the pressure intensity is same when the fluid at rest condition. That is a very important thing you need to understand. Okay. Now, for example, if you take a ball and if you press here like this, if you press here, so you are applying the pressure here at this point, but which is equally transmitted in all the directions. If you measure the pressure, so this will be equal to here and here, here. So wherever you find out the pressure intensity is same. What is the pressure intensity? It is nothing but force per unit area. How much force you are applying per unit area. So when you take the ball and if you press in this point, so what is the pressure created here? It is equally transmitted in all the direction. So we will try to solve some numerical problem, then you will understand in a better way. So this is one of the best example where we can use the Pascal law. Yeah. If you see here, now there is a small piston or a plunger. So this I am here used to lift the heavy vehicle, right? For example, what is the pressure intensity here? For example, here I am applying a force of F. So I am applying the force F. Because of the force F, this is the area, right? This is the diameter. If you measure, you can get the diameter. So area is pi by 4 d square. What is the pressure? Pressure intensity is force per area, right? So we know the force, that is weight. We are applying a force. We are applying here, and area we know, right? That is F by pi by 4 and d square, right? So force is equal to pressure into area. F1, P1, A1. So F1 is the pressure applied at this point, and A is the area. A1 is the area of the plunger, and P1 is the pressure intensity which is created because of the pressure F1. So if you see here the area is increased, right? So what will happen? So as per the Pascal law, we can say that the pressure intensity when the fluid at rest, here the fluid at rest condition, the fluid is not flowing, right? It is a container. The fluid at rest condition, when the fluid at equilibrium condition, if you apply the pressure, the intensity of the pressure, the pressure intensity, the pressure is transmitted, what is the pressure generated here, which is equally transmitted in all directions. So what is the pressure he created is P1. The same pressure, right? Here also the pressure is P1. So the pressure created, what are the pressure created here because of applying the pressure, which is equally transmitted to the here. So that means what is the pressure here? P1. What is the pressure formula? Force into pressure is equal to force per area, right? If you see the pressure is, but here the area is increased. How much? It is 10 times the area at this section, right? So 10 times the A1. So it is increased by 10 times. So what happened? This is a constant and this is increased. So the force is increased, right? If you see P1 into 10 A1, this is A2, which is equal to 10 times area. Diameter is increased 10 times. So this means force is increased by 10 times. For example, here if you apply 100 kilonewtons, so here the pressure, what are the pressure created can lift 10 into 100, 1000 kilonewtons weight. So this is the one of the best example where we can use the Pascal law for hydraulic lift. This you can call it as a hydraulic lift. So by applying the 100 kilonewtons, I can lift here 1000 kilonewtons. If I apply 10 kilonewtons force here, if I apply 10 kilonewtons force here, so I can lift up to 100. If I increase the area by 100 times, so it can lift 1000 kilonewtons weight if I apply 10 kilonewtons here, right? So this is the one of the best example. Anyway, we will try to solve some numerical problems, then you will understand in a better way. This is the one of the important application in Pascal law. Friends, and thank you for your attention.